Hello everyone. Today we will study how to solve integrals by substitution. And the idea of this video is to continue a series of videos in the context of integral calculus that will help us to understand how to solve some problems. We will follow some well-known problems, for example, from integral contest from MIT competition of integration, even a competence that is held in Medellin, Colombia, among other problems that will help us to know how to improve our skills in solving integrals. Okay, so as Polia said, the best way for doing math and learn math is doing math. So we will show at first what is the idea of the method of substitution, and then we will show how to tackle specific examples and how to see the differences and particularities of each problem. So at first, let's remember that an integral by substitution can be seen as a derivative of a function f evaluated in a function g multiplied by the derivative of g by dx. So a substitution is just like a chain rule. So this can be easily as f of gx plus c. Okay, so our idea in this context is to know how to identify gx and the function f and its derivative, and also the derivative of g. This is the difficult part mostly, the identifying what is the function g. Why is it the case? Because substitution is just to say like u is equal to gx. So if we use the substitution here, then we will obtain that this is the integral of f prime of, and we derivate of, well, of course, g prime dx. This is f prime u by du. And by the fundamental theorem of integral calculus, it is equal to f of u plus c. And then we return the substitution, and this is gx plus c. This is the same result that we stated before. Then it is just the first part was just like an integral version of the chain rule, and this is more like the method and how it functions. Okay, so now the best way to see the method is to see it in action. So how we will do it? Okay, first let's consider this integral. So this integral is taken from the math contest of Medellin, held in the year 2017. So it's the first integral, and for this problem they gave 2 minutes, but it's okay. We won't hurry up. We don't need it. We are learning how to tackle different kind of problems related with substitution instead of preparing for contests. In other videos we can make preparation for contests of this type, and we can study how to solve these problems and what is the kind of preparation that we require to have good results in them. So at first, how do you decide what is the substitution? The substitution mostly is the part that tends to be more like kind of complicated. For example, in this case, what is complicated? For example, I say like complicated, like something that is not linear. For example, if you have a plus b divided by c, this is a divided by c plus b divided by c. There is a kind of linearity here. But if instead we have c divided by a plus b, in general we won't have that this is c divided by a plus c divided by b. So we tend to attack to the terms which has this behavior, like they are not linear, and also they are the most complicated parts in the integral, and we will see later. Okay, for now let's solve this problem. So as I said and I stated previously, the substitution suitable in this case is x minus 1. And we will say x minus 1 at 6. There is not any advantage in doing that, because if we only left like x minus 1 equal to w, we will see that functions like dx appears here, dx is dw. Okay, no problem. And x by itself, because this value of x can be written as w plus 1. So all the terms can be written in terms of w, and there is no need to put something like to the 6th power or something like that. It's not required in any moment. So for now we are okay. Maybe later we have to use that, but for now no. So we will make, as the name said, substitution. So integral of, now what is x? X is w plus 1. And what is x minus 1? This is w to the 6th power. And dx is equal to dw. Okay, we obtained a solution of this problem that is more easily than previously. Why? Because previously we didn't know how to tackle the problem. Maybe we say, okay, why if we just use this problem and just expand the denominator? No, it won't work anything. Sadly, no, it's not the case. But if we make substitution like this, then we will have a more simple expression. And you will see, if we apply this first rule, w divided w 6 divided plus 1 divided by w at 6 by dw. As you can see, we transform an expression like this in an expression like this. So we impose a kind of linearity in the problem, and it helped to make it more easily. Why? Because if you do some algebra here, you will know that this is w1 minus 6 plus w2 minus 6 by the w. And this is the same that integral of w to minus 5 plus w minus 6 dw. Okay, we can continue working on this part in the following whiteboard. So this is the integral that we require to solve now, and this is equal to w to minus 5 plus 1 divided by minus 5 plus 1 plus w minus 6 plus 1 minus 6 plus 1 plus c. Okay, never forget plus c, because this is, if you put without plus c, then people will say, okay, this is the solution of a single integral, not of integrals. Even my professor of integral calculus had a joke with that, like, okay, I will give you 1 point for the solution that you obtained. I didn't put, people didn't put c, for example. Then I will put, I suppose that your integral is okay, but you didn't put plus c. So you have one function that is right and has that integral. Now, how much functions has the same integral? And the answer was, okay, infinite, because if you use sum, for example, plus 1, plus 2, plus 3, then infinite. Then I will do something maybe like this. I will write like this. It's okay. Then your score will be 0. Okay. So, okay. We won't want that we saw we will have this problem. And not only my professor, even in the contest, in this contest from Medellin, one friend had such problem too. He was solving integral, he did very well, but at the final he didn't put plus c. Okay, you didn't put plus c, and he on the contest was like, okay, you have two chances. If you lose 2 chances, you have 2 mistakes in 2 different problems, then okay, it's over. And then he lost because of that. So we will avoid repeating that such kind of mistakes. W minus 4 divided by minus 4 plus w minus 5 divided minus 5 and plus c. Okay, now we will make some algebra. This is w at okay, let me organize a little bit. 4w4 minus 1 divided by w5 plus c. Remember, what is w? W is x minus 1. So w is equal to x minus 1. We replace, we will take 4 by x minus 1 at 4 minus 1 divided 5 by x minus 1 at 5 plus c. Okay, it finished this problem. We could obtain the solution of this integral using substitution method at first to separate, and then some kind of algebra to obtain the integrals in functions of well-known operations. What I mean by well-known, maybe it's not. We can remember this, like integral of x at n by dx is x at n plus 1 divided n plus 1 plus c. Okay, of course n cannot be equal to minus 1, because in that case then we have natural logarithm of the absolute value of x. Okay, so we could solve this problem using substitution. Okay, until now I think we understand what is the problem here. Okay, how do the substitution works? Now let's tackle other problem similar to this one. So my second problem, okay, of course the problems that will appear here, they will tend to be more, even they can be problems from that include like partial fractions like this, but I want to avoid this situation. It's not a nice situation. Okay, for attacking a similar problem, then let me analyze this one with all of you. Okay, this is suitable integral. I like it. Okay, it's very similar to the other. So you will see that the structure from these problems are the same mostly. 2014, sorry. It means that this problem is from the same year. Okay. And in this case, the strategy is exactly the same. It doesn't change anything. So we'll say w is 1 minus x. Yeah? Why? Because you have two options. We'll say the options. Of course, maybe many people of you will say already, okay, and we know you will do that, but it's okay. I will just explain. So the first option is to use the theorem of binomial to expand this expression. This is crazy. You will have a lot of terms. You will have to. It doesn't deserve your time, your life. That's why the other option is to make substitution. This is another way to know. Like, okay, you can do by brute force using algebra. Okay, it can be done like that. For example, if instead of adding the integral, I put this integral, somebody will say like, okay, no problem, I can expand this. Oh, very good. It's very nice. Okay, did it. Yeah, it's right, you can do it, but if the power that appears is more and more big like this, or even it's not natural number power, then you will have problems. You cannot do that at all. So in this case, better to tackle this problem more wisely. So the way is to make substitution. So what is the substitution? Substitution tends to take the term that has more difficulties, that is not linear, that it has problems in denominator like this. So if we use x is very linear. Okay, later we will see that this is not always the case, and this is that. For now it works. Okay, we will take, this is x, and it's multiplied by 1 minus x to the 2014. And okay, we say w is 1 minus x. Okay, Let's write x equal to 1 minus w. Now the x is minus the w. And we are ready again to replace everything. So we replace y minus w multiplied by w at 2014 multiplied by the x, that is minus the w. Okay, here I will make some algebra here, then it will be like w minus 1 by w 2014, sorry, 14 by the w. And now we make more algebra. This is w 2015 minus w 2014 dw. And now this is w 2016 because we saw or we previously how to doing this problem, minus w 2015 divided by 2015 plus c. Okay, till now it works very well. And what will we do? Okay, let me take this expression just to return. What do I mean by return? Taking everything in terms of x, the original variable. Okay, here we are. So what is w? W is 1 minus x. Okay, replace 1 minus x 2016 divided by 2016 minus 1 minus x 2015 divided 2015 plus c. Okay, so this problem again is not so difficult. It doesn't take so much time. It can be done easily, but it's an interesting problem. Okay, let's propose another problem, and we will mix between substitution and algebra. The problem is the following. The problem is integral of dx divided by 1 minus sine of x. Again, they give us 2 minutes, but we don't care. Now we are just playing and learning a little bit, so it doesn't matter time for now. Okay, so what can we do in this case? What can we do in this case is to, okay, if we try to make a substitution, we will say, okay, what is the most complicated function here? It's like the denominator is 1 minus sine of x. One can say, okay, 1 minus sine of x is w. Then the derivative is more complicated because it's in terms of cosine. We don't have cosine here. No, we cannot see cosine. For example, I will make here like, okay, like somebody was thinking, like, why about we don't put this? It's possible, it can be solved like that. I'm not saying it's not possible, but at least I don't feel this is the most comfortable way because we have to do a lot of algebra. It can be solved using some properties of trigonometrical functions, but the idea is to be more wise and try to use some tricks of algebra too. This is a mixing between substitution and algebra. So now, how we can solve this problem? For solving this problem easily, instead of doing a lot of more complicated algebra, we will try to transform this 1 minus sine of x. How we can transform it? We can do it multiplying by its conjugate. Its conjugate is the same expression mostly, but instead of minus, we'll put plus. 1 plus sine of x by dx. Okay? Okay, sorry, here, by dx. Okay, this is the integral that we will perform. Now, we will do some algebra in the denominator. 1 plus sine of x divided by 1. Okay, here we'll make just a little bit to remember algebra. This is just a minus b multiplied by a plus b is a squared minus b squared. So we do this is 1 minus sine square of x by dx. Okay, by dx. and this is equal to 1 plus sine of x, and 1 minus sine square of x is equal to cosine square of x. How do we know that? How do we know that? Because we have to remember the trigonometric and Pythagorean identities. If we remember them, we don't have any problem at this. Anyways, okay, I copy, but I will put here the property that I use is 1 is equal to sine square plus cosine square of x. Okay, we are ready now to continue our problem. So what will I do here? Here I will separate. Why do we do that? When we have this kind of expressions where there is assume in the numerator, like there is no much relationship in the denominator, then one of the things that you try to do is to see if it's possible to separate, and maybe separating the elements of the algebraic expression, it will be possible to make the calculation. So that is what we will try to do, and let's see if something happens. So this is 1 by cosine square of x plus sine of x divided by cosine square of x by dx. Okay, now we have more, seems like there is no so easy now, but now we have to remember. Now another part important of integrals is to remember mathematical properties, geometrical properties, trigonometrical properties. So you have to remember that 1 divided cosine of x is the same that secant of x. Okay, why is it helpful here? Okay, let's see. Because cosine squared, then secant square of x, and I will separate by dx. So given that I will separate it, I don't need this parenthesis, and I will make more tens plus sine of x divided by cosine square of x by dx. Okay, so the first integral can be found and is popular. It can be found in trigonometrical, let me remember, in trigonometrical tables. Yes, so when you start your course of integral calculus, mostly you try to remember, okay, the derivatives, more common derivatives. So one of the most common derivatives is the derivative of tangent. Yes, it means specifically integral of secant square of x, secant of x at square, I mean, by dx has integral tangent of x plus, sorry, let me move a little bit, it's tangent of x plus c. Okay, and now I can complete it, tangent of x plus c. Okay, so we can replace tangent of x. Do we require to put a plus c? No, we don't require. Why? Because we haven't finished. We have to complete another integral. When we complete the other integral, then we will put plus c. And given that c is arbitrary constant, then it doesn't matter. It's okay. Okay, now we were talking about substitution. We cannot lose our focus. So focus now here. So which relationship exists between cosine and sine? Okay, cosine is the denominator and it's at the square, and sine is in numerator. And you remember that the derivative of cosine is minus sine. So okay, it's possible to make a relationship here, and this relationship will be our substitution. Then we will say, okay, W is cosine of x. Then dw is minus sine of x by dx. Okay, I will just take this, copy and paste here. Okay, let me just remove the plus. Okay, so we can replace. Okay, so what is the idea here? This is more complicated than the other problem, because the other problem was like just like dx is dw, there is nothing to do, or dx is minus dw, it's okay. But here is more complicated, like dx is dw divided by minus sine of x, or dw is equal to minus sine of x by dx. So there are two options. The first option is, okay, you must aware of the fact that here appears this term and here appears this term. So you can say like, okay, minus dw, because I put the minus to the other side, is sine of x by the x. And you say, okay, it is what I expected. And then you can conclude like this is the integral of minus dw, because the numerator is known, divided by w squared. And okay, we have a more simple integral than previous one, and it can be solved using the explanation that I provided previously about integral of polynomial expression plus c. Okay, this is minus w to minus 1 divided by minus 1 plus c, and this is the same that w to minus 1 plus c, and this is the same that 1 divided w plus c. It means 1 divided cosine of x plus c. Okay, we have obtained the integral, so we can conclude. What can we conclude here? So the last part, if we can say last part, because we have finished already. What we require to do now? We require to make more aesthetic, like we have to provide an answer as to table 1. So well, how do I provide the answer then? I just need to copy and paste what we did previously and join the elements, and we could see that this integral is 1 divided cosine of x plus c. This is the answer to this problem. Okay, so far what we have done, we have calculated the integral, the substitution of two cases where the algebra was too complicated to make expansions, and it was more suitable to introduce substitution. And also we solved one problem where we required to do a substitution, because on the way we decide to follow form in which we did some algebra, and then the problem appeared like this. So these problems are more intended to manage, for example, yourself for examination, for a competence, a contest. So they are more intended in this direction. That's why maybe you will find some of them more maybe you could find them more advanced a little bit. Okay, so and this is our video for today. Thank you so much for watching. We hope that we will continue offering this series, specifically in techniques of integration. Yes, so the techniques of integration like substitution, integration by parts, integrals of trigonometric functions, trigonometric substitution, fraction parts, and other kind of substitution even will be studied here widely. Okay, for now this is all for today. Thank you so much for watching. See you later. Have a good day.